Oh my goodness, everybody. I hope you're having a great night. We are on day 13 of the Advent of Code, which is the exact hump day of the full thing. We've done 12 days. There's 12 days in front of us. We got this one right here to knock out and we'll be over halfway done, which is kind of sad. If we take a moment and we look at our private leaderboards, looks like one of my coworkers is about half a day behind, 1 day behind, 1.5 days behind, and then people sort of fall off from there. So people could jump ahead to today, I guess, but we probably shouldn't expect that. And we've got a nice commanding lead, so we can continue on there. And on the other one, oh yeah, it's been 6 days since anybody's had any problems. We'll be fine. Got about 1 minute and 45 seconds left, so let's do a little bit of a mental check-in with ourselves. It's been a pretty long day at work dealing with a escalation. Lots of stuff going on there. But we had a pretty good day today. Over the weekend, we needed to win in our fantasy football league in order to make it through. And the New England kicker actually kicked us through to the playoffs. Unless he missed a bunch of field goals since I last checked. I should actually check that right now. Here, why don't we put that over here so we can all see? And if we, come on, Fantasy Cast. Yeah, all right, game's over. We've officially won the week. We are into the playoffs, unless I have done a terrible job of understanding how the playoff structure works, which I don't think I have. So that's good. Still about 1 minute left until we get started here. We've already got our code up and ready to go. And again, it looks like we're a fine font as long as you're on a computer. So should be fine enough. And we just wait to get started here. Kind of nice to have this sort of cadence or schedule to stuff every night, but it is a little annoying that it's at 9 p.m. It would be nice if this were at 11. That would be a good time for me to be able to do this, work pretty hard, and then fall asleep knowing that I've done a good job. How we doing, Hippoism? Good to see you. Another night, another coding challenge. We wait for it to unlock. Haha. Yeah, decent though. Oh, let's just wait our 15 seconds until we get started here. No huge complaints. I did make a new YouTube channel in order to upload the VODs of this, and apparently just posting videos every day is the secret to the YouTube algorithm. I've gotten 500 views in the past 2 days. It's been wild. Here we go. Let's get started. Day 13, Distress Signal. You climb the hill and again try contacting the elves. However, you instead receive a signal you weren't expecting. A distress signal. Your handheld device must still not be working properly. The packets from the distress signal got decoded out of order. You'll need to reorder the list of received packets, your puzzle input, to decode the message. Your list consists of pairs of packets. Packets are separated by a blank line. You need to identify how many pairs of packets are in the right order. For example, packet. Packets consist of lists and integers. Each list starts with a bracket and ends with a bracket, and contains 0 or more comma-separated values, either integers or other lists. Each packet is always a list and appears on its own line. When comparing two values, the first value is called left and the second value is called right. Then, if both values are integers, the lower integer should come first. If the left integer is lower than the right integer, the inputs are in the right order. If the left integer is higher than the right integer, the inputs are not in the right order. Otherwise, the inputs are the same integer. Continue checking the next part of the input. If both values are lists, compare the first value of each list, then the second value, and so on. If the left list runs out of items first, the inputs are in the right order. If the right list runs out of items first, the inputs are not in the right order. If the lists are the same length, and no comparison makes a decision about the order, continue checking the next part of the input. Nope. And no comparison makes a decision? Okay. If exactly one value is an integer, convert the integer to a list which contains that integer as its only value, then retry the comparison. For example, if comparing 0, 0, 0, and 2, convert the right value to a 2, a list containing a 2. The result is then found by comparing 0, 0, 0, and 2. Using these rules, you can determine which of the pairs in the example are in the right order. Compare 1, 1, 3, 1, 1, 1, 1, 5, 1, 1. Compare 1 versus 1, compare 1 versus 1, compare 3 versus 5. Left side is smaller, so the inputs are in the right order. Let's go back to lists. Compare the first value and the second one. So we want to compare the values and stuff. This is not a great instruction. 1, 2, 3, 4, and 1, 4. 1 versus 1, 1 versus 1, we're good. Compare 2, 3, 4, and 4. Mixed types. Compare 2, 3, 4 versus 4, 2, and 4. The left side is smaller, so the inputs are in the right order. Compare 9 and 8 versus 7. Then we compare this. Then we convert 9 to a list. Then we convert 9 versus 8. The right side is smaller, so the inputs are not in the right order. 4, 4, 4, 4, 4, 4, 4. We compare these, they're fine. Compare them. The left side ran out of out of items so the inputs are in the right order. Compare 7777, 777. Right side ran out of items, the inputs are not in the right order. Compare bracket and 3. Left side ran out of items, so the inputs are in the right order. Pair 7, compare brackets and brackets. Right side ran out of items, so the inputs are not in the right order. Huh, this one's a weird one, but good to note. Compare 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 0, 8, 9. 1, 1, compare this, compare 2, compare 3, compare 4, compare 5, compare 6, compare 0. Right side is smaller, so the inputs are not in order. What are the indices of the pairs that are already in the right order? The first pair has index 1, the second pair has index 2, and so on. In the above example, the pairs in the right order are 1, 2, 4, and 6. The sum of these indices is 13. Determine which pairs of packets are already in the right order. What is the sum of the indices of these pairs? To begin, get your puzzle input. That is long. Okay, cool. So first what we want to do is we want to read the lines into comparison. And we also want like int index equals 1. Next what we want to do is we want to grab string left equals scanner dot next line, string right equals scanner dot next line. Then we want to do some comparison. Then we just want to do a scanner dot next line to just grab that thing, and then at the end we want to do index plus plus int sum of indices equals 0. We're going to want to add stuff. So and then we want to print out sum of indices plus sum of indices. And so we basically just want if is in order left right, sum of indices plus equals index. Great. So now we need the private static method. Private static boolean is in order string left string right. So let's see. Is it always lists? Your handle device conveys pairs of packets. Packet range. Let's see. Do these all start with a left bracket? I'm looking for a line that starts with not a left bracket. I think we're okay. So far, it seems fine. Okay, cool. List integer. Nope. Undo that. Alt enter. Decoded left equals parse string into list left list. Oh, it's not. It's like a list object. List object. List object. Decoded right equals parse string into list right. So let's write that, and then we'll come back to this. Private static list object parse string into list string string. So first of all, if string dot char at 0 does not equal this, then we want to throw a new runtime exception. Failed to parse string into list plus string. Great. So we've got the thing there. Now we want a string. So now we just want to strip out the outer brackets. So string equals string dot substring. Beginning index is 1 and end index is string dot length minus 1. let's call this string without brackets. And then we want this, we can't quite just, what I was thinking is, oh, we'll just split it on commas. But if we split it on commas, then we're gonna get like weird stuff like this. So we actually need to split it on, oh, this is hard. Okay, yeah, I want something slightly different, actually. Yeah. So this is fine. I actually don't care about removing the, well, yeah, we can remove the brackets, that's fine. Elements equals, without brackets dot split, let's split it on commas. And then, splitting on commas doesn't work either for nested lists. So first we want if without brackets dot caret 0 is this. Let me think about how to parse this. I basically want to like split this into like subsections. I just need like the right recursive parsing of the list. So as I go through, if I see a left bracket, I want to keep going until I see an equal number of left brackets and right brackets. Oh gosh, sorry, I'm trying to think this out. This is just like an annoying parsing problem. This shouldn't actually be this hard. It's been a long day, I tell you. Okay, why are we upset here? Probably because regexes need to be strings. That is fair. What are we upset about? Okay, so let's see. We know the outer things are going to be brackets. We can remove those. We can... We can't go from the outside. Do we just want to, like, when I read this, I just go like, okay, here's the beginning of the whole list. Okay, we're in another list. Let me go make another list. I'll recursively call this from here until here. And then there's a comma, and then I'll keep going about my business. So in that case, we want, like, int pointer equals 1. Skip the first bracket. While pointer less than string dot, nope, length minus 1. So then we know this is a list. So list object list equals new array list. There we go. While pointer is less than string length of 1, blah, blah, blah. If string dot char at pointer is a list, then find the length of this inner list, parse that, and insert, and we'll worry about doing that. Otherwise, we want to well, come on. while string dot caret pointer not equal comma and string dot caret pointer not equal this. Those are the only two things it can be, right? When you're parsing an int, you can either run into a comma or you can run into an end of list plus plus pointer, and then we want int value equals, I should actually probably call this integer so that it plays nicely. Value equals oh, come on. Int value equals integer dot, wow, I'm just not firing on any cylinders today. Parse int string dot int first index equals pointer. String dot substring, we want to start at first index, we want to stop at pointer. That should be right, because it's you tell it up until you're like one past. And then we want list dot add value. Great. So now we need this find length of the inner list, parse that, and insert. Okay, great. Sorry, got a message. My girlfriend's not feeling well. It was important that I deal with that. Okay, find the length of this inner list. Int bracket count equals 1, while bracket count is greater than 0. First, we want to pointer plus plus. If string dot caret pointer is this, then bracket count plus plus. Else if we want this, but we want the closing bracket. Closing bracket, and now we need some parentheses. I don't know why those didn't get copied. Then bracket count minus minus. That's kind of all we need to do. And then what we need to, we need int start of inner list equals pointer. Then we want list object inner list equals, this feels like we could just use JSON. It feels like we're writing a JSON parser now that I think about it. But we're not gonna sweat that. We're just gonna keep writing our parser. I don't care that this is dumb. At this point I have to do it. Equals sparse string into list, string dot substring start of inner list pointer. Then we want list dot add inner list, and I think that should do fine. And then at the end of this we need to return list. So that should do fine. In fact, let's move these to the bottom of the file because we know that part 2 is going to involve some of the same stuff. Okay, so when we look at two lists, we want to compare their values. Let's see, for int I equals 0, I is less than math.max. Sorry, math.max. Decoded left dot size, decoded right dot size plus plus I This needs to be a semicolon. Let's see. Object left lm equals decode left dot get I. Object right lm equals decoded right dot get I. If left lm instance of integer and right lm instance of integer, if and it's if sorry, int left lm is greater than int right lm, return false, right? Let's see. Both values are integers. The low integer should come first, and yeah, so that this is fine. If they're equal, then we're cool. The left input is lower than the right input. The order is the right thing. Okay, cool. Else if they are in order, then we're also done, I think. This return true. Otherwise, we continue. Else if left lm instance of list and come on, right lm instance of list. That's in fact, we're just gonna let's call this up higher. Parse string into list left, and parse string into list right. There we go. What are we upset about? Now this needs to take in list object left list object right. Now I can get rid of this. First, let's just shift F6 and just make this left, and then let's shift F6, just make this right. And then we can just delete these two lines and we're good. Oh, look at that, so much better. Oh, we can't. Yeah, let me see this actually. This is fine. So the inputs are fine. Make this like a Boolean so we can return null. If left lm, come on, dot size? Yeah, there we go. Is less than, is that right? Do we just compare the list sizes? No, we only compare the innards. Those are compare the first values and so on. If the less list runs out first, blah blah blah. Okay, cool. So we can do that check actually down at the bottom. If left dot, nope, come on, size is less than right dot size, return true. Okay, if the list runs out if the list of right runs out, else if, and now let's do the reverse. Man, this is really tiring. Greater than right dot size. Great. Return false. The lists are the same length and no comparison makes the decision about the order. Continue checking the next part of the input. Otherwise we just return null. So we don't have to check the list themselves. We could just say if is in order left lm, right lm, not equal null. return, in fact, we should Boolean lists in order equals this. We probably have to cast these. Gross. Man, this statement reads awfully. Can we just do this? No, I actually want to put object there and see if we can do that. I think things get weird if we try and put the question marks there. If they're not lists of objects, I'm just going to get real mad. Object cannot safely be cast to list object. Class object is in there. Each class. Fine. We'll just do that. I'm just going to know that that's right. If, come on, lists in order is not equal null. There we go. Return lists in order. Otherwise, we just keep going. And then else, and we're going to do a little bit of casing. If left lm instance of integer one second. There's this weird case. Compare this and this. Compare this and this. So now we have a list and we have nothing. The inner list should be null. Yeah, right side ran out of items, but the left side isn't run out of items. So if the right side ran out of what? Wait, what? The left side runs out of items. Okay. Huh. So we have to like deal with null. But first let's deal with the case of the integer. And right lm instance of list. Let's put this here just so that it reads nice like everything else. And let's copy this. Oh yeah, this. And then we're just gonna switch these, and then we can just deal with the insides. There we go. So if this is the case, then we want left lm list object wrapped integer equals new array list. Wrapped integer dot add left lm. Then we want this same thing, except we want left lm to instead be wrapped integer. And we can copy this and just replace our lefts with our rights and our rights with our left. Right lm. We can call this just left lm actually, and then just whoop, we flip it, which you guys can't see because it's below the fold. There we go. And then if not, list is in order, whatever. That should be fine. Else if right lm is null and left lm not equal null, return false. Else if left lm is null and right lm not equal null, return true. And there is no other case, so we should be fine. We'll just keep going forward. And I think that should be fine generally. I think that should generally be okay. So let's see whether or not we got this even close to right. So let's copy this input because we sure as heck are not copying our gigantic input until we at least try this. This needs to say level 13, part 1. Thank you very much. And let's try running it and seeing what we get. An exception. File not found for input string, whatever. Okay, come here. What did I do? There's part 2. Level 13 data.txt. FileNetPound. Oh, but everything's just FileNetPound. Because this says exception. That's okay. All right. Oh, and this says 4 input string something. I see. Okay. Did we just assume stuff was an integer if it wasn't a list? Let's see. So we need to deal with the empty list case, right? We can do this one by one, but let's see if string dot char@, pointer, what do we want? Like character dot is digit. That should do it. And then in the other case, we're just going to insert a null. I think that should do it. List.add. If you just get 2 things in a row, that's just how it's going to be. Oh, and it's also probably going to get mad. Oh, this is going to get mad like right away. Okay, let's just go to here. Let's debug and let's see what the first one looks like. So the first string looks like this. Fantastic. List this. Pointer is 1. That's not true. This is a digit. This. So now pointer is 2. That seems great. And then we know at the end of each of these, no, we don't. Well, we could just add null. If string dot char@, pointer is comma. Let me think about that actually. No, that's right. If this is a comma, there's an extra thing here. Pointer plus plus. There we go. That should help us some. Let's try re-debugging. It's a good thing this is not a lot of tricky little logic. Great. And so now our list has a 1 in it. And now it's got a 3. So what happens if we just step up? So now we're parsing the same thing, and if we step up, left is this, right is this. And so now if we step into it, is in order. So now we have left, which is this, and right, which is this. Let's run this a little bit. They're integers. They're fine. They're not different, so we're cool. And whoa. Yeah, and it's getting mad at us now. Of course it's getting mad at us. Okay, let's re-debug that because we missed the important step there. Stop and rerun. Step up for me, step down, step up for me, step down. Oh, nope, I messed up there. Stop and rerun. Step up for me. Down. Got parse, string in a list. Step up, step into. Okay, so we have, nope. This and this, 113, 115, blah, 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 blah. This part's fine. This is also 1 and 1. These should be different. If left lm is greater. Oh, well, this if left lm is less than, of course. Oh my goodness, what am I doing? Okay, now run it. You're gonna break, but I gotta see you break interestingly again. 1 second, stop. Run. 1, 2, 3, 4. We've got an infinite loop, ladies and gentlemen. Okay, so we already know that this works. Let's put a thing on the comparison. That's the part that I'm worried about. So this part's fine. No. You can play. Thank you. Cool. So if we step up here, no. Step out. Step out. Go down. This. Great. Person to the left. Yeah, sure. Let's on here. Cool. So we're good. List is this. Here. Yep. And then we just keep going. Well, that's probably why we have an infinite loop. No matter what, we have to move the pointer forward, which we haven't been doing. That's dumb. Okay, let's try this again. Stop and rerun. And nothing's happening on my work phone. Index 3 out of bounds for length 3. All right. We'd have math.max somewhere. This is for parsing. This is for lists. This should be math.min. That is, of course, why we're having that problem. File not found, no line found. And if we look here, that's probably because our last 2 lines do this. Great. Now let's try it again. Really? And if we go again? Nothing? Sum of indices 13. Is that right? That is right. Okay, so it's just because we didn't have the right number of lines going on here. Okay. All right, let's try it on our bigger input and see if anything gets wacky or not. But I'm very comforted, actually, that this worked, even if it requires a slight modification of the input. 5675. If this worked without a hitch, we are amazing at this. We are amazing at this. Part 2. Now, you just need to put all of the packets in the right order. Disregard the blank lines in your list of received packets. The distress signal protocol also requires that you include 2 additional divider packets. 2, 6. Using the same rules as before, organize all packets, the ones in your list of received packets, as well as the 2 divider packets, into the correct order. For the example above, the result of putting the packets in the correct order is that. Afterward, locate the divider packets. To find the decoder key for this distress signal, you need to determine the indices of the 2 divider packets and multiply them together. The first packet is at index 1, the second packet is at index 2, and so on. In this case, the divider packets are the 10th and 14th. 1 second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cool. So we're going to have to add 1 to our indices. So the decoder key is 140. Organize all the packets in the correct order. What is the decoder key for this distress signal? Great. So we've got a... Okay, so this is actually not so bad. While scanner dot has next line, string line equals scanner dot next line. If line not equal this, right? Is that right? Dot equals, there we go. Which I think is all should be there, because it grabs it by the line. Then we want, so we have a list of objects. List object. It's a shame that we did not wrap this in an object. List of packets equals new array list of those. Parse string into list. Then we want to list of packets dot add this of line. And then we also want to do list of packets dot add, and it told us to add 2. And then list of packets dot add Oh, and this needs to be wrapped in the parse string into list function. Great, and so we want this same thing, but we want it for 6. My goodness. And then we want like list dot sort, list of packets dot sort new comparator. So is in order. So if is in order O1 O2 equals null, return 0. Actually, here we go. Boolean is in order equals this, so we don't compute it too many times. And then we want if is in order equals null, else if is in order, that means left is less than right, so we want to return -1, else return 1. I think that's right. Let me look at comparator real quick. Compare. Can you Java override object compare? That's what we're looking for. We've done this several times. Compare. Overriding equals to compare to complex objects, blah, 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 blah. Where are the data members and return? That's not helpful. Reason for printing not good compare C1 to C blah, 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 blah. That's overriding equals. Override compare to. Blah, blah, blah. Just give me compare. I just need to read what the Java doc is. Yeah, just take me there. Compare to. If the object is greater than return a positive number. Got it. Okay, cool. We did it right. Int first index equal second index. So we actually want to list object first spacer equals this, and we want first spacer this. And we want the same thing but for second spacer, actually, which is going to be a 6 second spacer, second spacer. So then we can just go int first index equals list of packets dot index of first spacer plus 1, and second index equals list of packets dot index of second spacer plus 1, and the decoder key plus, and then we want first index times second index. That should be fine. Let's change this to part 2, and let's see if we did this correctly. This should run just fine though. Okay, 2383. We nailed it. Oh yeah, that is excellent. Let's go to the leaderboard. Let's see our personal stats. How did we do? 2378, 1971. We gained 400 spots because the second part was so chill for us. Amazing how close these placements are. We are getting blown out of the water by people that are just using JSON parsing to read it's not like a JSON object, but it is, there's something to parse lists like that way easier. But it was fun to write our own little parser. And if we look at the leaderboards, bam, nobody has even done. Although Brian did the second part of yesterday's, so he's catching up a little. Yeah, we're the only person who have done today's at all, and obviously nobody has done any of the other one. Okay, well, let's begin as we always do with the post solution by copying this in and making our problem statement nice. So, oh nope, we actually can't do it this way. You definitely did const packet equals eval line. Yeah, I mean, people using JSON parsers or other languages or whatever. I wish that they had made it something that you couldn't just like string replace and then parse and whatever. Like, it's nice when you have to like write a good parser. I think that that's a good thing for people to learn how to do. So I'm a little disappointed that they didn't have people do that, but you know, that's just me. How you doing, by the way, the Mass 3212? You having a good night? How many pairs of packets are in the right order? This period is not bolded. Bam, look at that. For example, oh, look at how nice this is. And if we take this sample input and we put a bunch of things at the end, oh, it's gonna show up as a nice little table in our MD file. Line starts with a this and ends with a this. Happy you actually got today solved. That's fair. Have you done all of them so far? Blah, blah, blah. Just called left. Second value is called. Let's keep going over. Right. Then and now we got to make a little list boy. Wish that some of these would automatically copy over, but alas. If both values are integers, and the lower integer should come first, blah, blah, blah. If both values are lists, nothing's there. If exactly one value is an integer. Got 2 stars for every day so far, except yesterday. Oh, really? That's kind of, if you want hints on you, well, first of all, I have a YouTube channel, so you can just watch the full VOD of yesterday if you want to figure out the second part of yesterday. But I'm also happy to talk it out if you could use a little bit of a, if you want a second brain on it. Though, to be clear, I have solved yesterday already, so I can't claim to be anything other than someone who already knows the answer. But I can go look at what my answer was and then tell you if there are any good. Oh, I remember yesterday actually. I think people were mad about it. People being people in my work chat because there was like a trick involved. This all seems great. Oh, we have to do the bolding in here. Okay. In the right order. In the right order. Not in the right order. In the right order. Not in the right order. In the right order. Not in the right order. Not in the right order. Oh crap! And this doesn't belong in there. Get out of here. This goes back here, and oh, would you look at that? Things are so much better. That's fine. You basically know what you need to do. It's actually implementing it that you've had trouble with. I'd be curious to hear what you think the solution is, because I found that once I knew what the trick was, implementation, given that I had done part 1, was trivial for part 2. Though it could be true that I had a particularly nice implementation to be able to port over for the problem, which is not always the case for me. But in this case, it was. My answer was this, and what is the sum of these pairs? Wonderful. Mix of DFS and A star. Oh, sorry, I'm thinking of the one from 2 days ago. You're right. Yesterday was the graph one. Yeah, I found. Yeah, I did not struggle with part 2, but that's cool. If you know what to do, far be it from me to give you advice you weren't asking for. I mean, to be perfectly honest, it's a little on brand for me, but you know, we're trying to learn. We'll just we'll shut up here for a second and let you keep on keeping on. No reason for me to sit here and tell you what to do in your own advent of code. It's your life. Do what you want. By the way, how did you get into coding? Are you a student? Do you do it for a job? What's got you interested in the field? What brings you to Advent of Code this year? Are the 10th and the 14th, so the decoder key is this. Fantastic. There's all the packets. What is the decoder key? Come on. What is the decoder key for the distress signal? The answer was this. Basically had an interest in programming since high school. Fair enough. All right, we got this. Let's go look. Let's add some comments to our thing. Grab each pair of, oh, and let's move this down to the bottom and make it play nice. If scanner dot has next line, and we can just wrap this in that, and then everything should play nice. Lines, compare them, add to total if they're in order. That's fine for this one. Grab, come on, each line. Check if empty, put into list. Insert signal packets. You do admin code every year to keep your skills sharp. Fair enough, me too. I'm a software engineer by trade, but I now manage a team of 7 people. I'm not an engineering manager, I'm a TLM, but I don't have a whole lot of time to sit here and just do implementation stuff. And I, once upon a time, like to do a little bit of competitive programming, so it's nice to be back into it. So I totally hear what you're up to there, the Moss. Perfectly reasonable. Sort the list using the comparison operation we generated in part 1. In part 1, find the indices of the spacer packets, use them to compute the answer. Wonderful. Is in order. Oh crap. I missed a star. Now we gotta delete this and do it again. Sorry. Oh, look at that. So much better. Returns if left is before right, according to the puzzle semantics. And we're just gonna put C readme because I don't want to write it. And let's put a couple of things. If they're both integers, return if not equal. Okay, we're actually not going to do that because it's going to get too hard to deal with. We can just put actually this here, both integers, both lists, left integer, right list, left list, right integer, and then the nulls speak for themselves. Check if one array entered for the other. These two are the same. Ignore for the purpose of checking higher order lists. Wonderful. And this needs to be a java.comment. Returns a list object from the given string, parsing all inner lists as necessary. Will return an empty list if fed, and that seems fine. Except for what we're gonna do here is find the length of this inner list, part that, and insert, which is fine. Parse until the end of this integer, then insert. Blah blah blah. Should be good. Correct for end of integer issues. Wonderful. Okay, cool. Now, let's explain today's solution from the top. So we are given a list of pairs of packets, and packets get compared. Each packet is a list, and packets get compared element by element. If they're both integers, then you keep moving, and you keep moving, and then if the first one is less than the second one, then you're cool. If the elements are lists, then you unspool them and then compare their insides. And if one is an integer and one is a list, then you turn this into a list of length 1 and then return. Now, if the two lists are of different length, you return that they're in order if the first list is of length less than the second list, but only after you parse the inner elements. So it's an inside to outside ordering check. So there are a bunch of examples, but what do we need to do this? So first we grab the pair of lines, and then we parse each line into a list of objects which might contain other lists, and then we'll call isInOrder on it. And this returns a capital B Boolean. It would have been smarter to return an int like it was a comparator, and then we could just have it be a comparator, but oh no. We end up doing the same thing elsewhere. So what we do is for the two lists, we know that they're lists because the outer objects are always lists, so that's fine. And this is going to recursively check. So if then it checks each of the elements in each list, and it says if they're both integers, compare them as integers. If they're different, return a value. If they're both lists, just call this on the thing, and as long as we don't get null back, return that value. If one's an integer and one's a list, wrap that integer into a list, and then compare those two things, and then if that's not null, return the value. Same with this. And then if one of them is null, return based upon whether or not the left one is null, which is what you would want. When you run out of stuff, then you're going to get, then you want to check whether or not the lists are of different length, and then return based on that. And then otherwise, like everything has been the same the entire time, and just return null. And so if you do that, you get the right thing, and then you just keep track of the index that you're currently working on, and then you sum all the indices where this ended up being true. Easy enough. For part 2, you parse all the same things, and you just insert them to a list of objects, or a list of packets. And then we insert these two spacers, and then we basically put them in order according to the in order notion of packets from part 1, and we use that to generate a comparator, where they're either equal, they're left, or they're right. Then we find the index of the two spacer packets that we're asked to insert, and then we multiply those to get our decoder key. So that's all it really is you parse some stuff, and then it's just the implementation of the logic that's given. There's no like algorithms or anything that we need to do there. I think that's all I've got for this one. If this was useful or pleasant to you, I would ask that you click follow if you're on Twitch, or if you're watching this later on the VODs on YouTube. Click like or subscribe or leave a comment, or I don't know, do whatever it is that people do. Something algorithm engagement. In fact, I'll give you guys a little Easter egg here. You can see this YouTube channel went from no views to like a gajillion views in the last couple of days. And if you guys click on some stuff, then the line go up. And I like it when line go up. So if you wouldn't mind, I'd appreciate it. If you do mind, that's totally fair. All right, I'm done complaining at you guys. I think that's all I got for you tonight. Have a good one.